QAM is quadrature amplitude modulation. Both QAM stands for quadrature amplitude modulation. This modulation techniques utilize both the amplitude and phase variation to represent binary data. The QPSK modulation uses bit splitters and two multiples with the local oscillators. 2-bit sent to parallel converter and summing circuit, and the basics of QAM 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 block diagram is following block diagram as shown in the figure. First one is odd bit and even bit. The input data is given to the binary digital data. We have to give a sequence of 1 and 0s. Then given to the odd bit and even bit. There is split into 2-bit serial to parallel converter. Even bit given to the 1 modulator, and 2 modulators are there. Into marks is mentioned. PSK 1 and PSK below these 2 modulators. In between we have to use a phase shifter, phase carrier, and this will be a 90 degrees phase shift. And another block is local oscillators, and split it to bit and connected to the even bit is connected to the upper portion of the modulator, and odd bit is connected to lower portion of modulator. In between we have to connect a phase shifted by 90 degrees, and given to the 90 local oscillator is given to the both oscillators. Then we have to add it phase shift of the two signals. Amplitude and phase both are variation, and added to this summer get to output of QPSK. And this is the at the modulator input the message signal even bits, second bit, fourth bit, sixth bit extra, and odd bits. First bit, third bit, and fifth bits extra are separated by the bit splitters and are multiplied with the same carrier to generate the odd BPSK. Phase shift keying and even phase shift keying. PSK Q signal is anyhow the phase shifted by 90 degrees before being modulated. We have to see that QPSK phase shift how to modulate the bit. We have to 2-bit transmission of data. Bandwidth is 2-bit. QPSK waveform 2 bits input as follows, which shows the modulator results at the different instants of binary inputs. The carrier signal is there, and we have to take a modulating value from 2 bits 0 0 1 0 0 1 1 1. 0 means 0 bit, and 1 0 is 2, and 0 1 is equal to 1, and 1 1 is equal to 3. The phase shift are 0 0 mean phase shift is 0 degrees, 1 0 mean 90 degree 180 degrees phase shift, and also this will be according to the amplitude will be shifted to the above 90. Then 1 1 will be shifted to the 135. This way we have to shifted the phase and the amplitude will be changes as positive voltage or negative. This is the way we have to sequentially shifted the binary data. The advantage of QAM, the major benefit of QAM is modulation variant is sufficient uses of bandwidth, and this is due to the fact that QAM represents more number of bits for carrier. For example, 16-bit QAM maps 4-bit for carrier, 64 QAM maps 6-bit for carrier, 256 QAM maps 8-bit carried, and so on. And disadvantages of QAM is quadrature amplitude modulation. In this amplitude phase, both are shifted. Modulation is more susceptible to the noises. Noise will be less. Due to this, QAM receiver is more complex compared to the receivers of other modulation types. As QAM uses amplitude component of the signal to represents binary data, linearity needed to be maintained. Hence, linear amplifier needed, which consumes more power. More power. This is the way we have disadvantages of the QAM.